Hi and welcome back. I wanted to help you guys out in my calculus class by putting together just a video for doing some basic differentiation with the product and the quotient rule examples as well. So just looking at some basic ones that we have written right here, I wanted to just show you that for our derivative for 3x squared minus 2x plus 4, we know that f prime, just by the power rule, the 2 comes down, multiply by the 3, we're going to get 6, subtract power by 1, so we're going to get 6x, and then right here we're going to have the same thing, power rule, so just 6x minus 2. So that was just a basic one with a polynomial. Going across here, we need to be able to rewrite this one first, so we're going to put 5/3, and we'll bring the x up top, and when we do the power rule now, the derivative will be a -3 times and 5/3, so that's just going to give us a -5. X, subtract power by 1, -4, and then therefore we rewrite it with no negative exponents, so we'll have -5 over x to the 4th. So that one we had to rewrite first. Here we have another polynomial, but it's got a trig function in it. We'll do the power rule to start. So f prime again is going to be, by power rule, 10x. And then we have the derivative of cosine. The 3 in front doesn't matter, it's just the coefficient. The derivative of cosine is negative sign, so that negative with the -3 is going to be a plus 3 sine x. So there's your derivative for that one. This one usually confuses people because they just see the x over 3 and they're not sure what to do. You got to remember that that's just like a coefficient of 1/3. So your derivative for x over 3, or 1/3 x, is just 1/3. So those were some basic examples right there of just the power rule, rewriting, a little bit of a trig function there. Now I want to get into some of the more difficult stuff with the product rule. And I have the product rule written out here with the notation, and there's two things that are multiplied. So again, like we talked about in class, we read it out loud here. That's the first times the derivative of the second plus the second times the derivative of the first. So knowing that this is our first one and this is our second one, now again, we could FOIL this out and do the derivative, but the product rule is a shortcut. So I'll write down first, which is the x squared minus 3, times the derivative of the second, 2, plus the second, 2x plus 5, times the derivative of the first, which is 2x. And now all you have to do is distribute and combine like terms. So if I distribute the 2, I'll get 2x squared minus 6 plus 4x squared plus 10x. Combine some like terms, x squareds will have 6x squared plus 10x, and then minus 6. That's going to be our derivative right there. Another one here, again, we got two things that are being multiplied. So we will have first, which is 4x cubed, 2x plus 1, times the derivative of the second, which is -3, plus the second, -3x minus 4, times the derivative of the first, which is 12x squared plus 2. And again, we're going to have to combine some like terms here. So the first thing I'm going to have to do is distribute the -3. So I'll have -12x cubed minus 6x minus 3. I'm actually going to have to FOIL this out over here. So I'm going to have a minus 36x cubed minus 6x, and then a minus 48x squared, and a minus 8. So we're going to have to combine some like terms here. So I got a -36x squared and a -12x squared, so that's a negative, what is that, 48x cubed. And we have a -48x squared. And then -6x, another -6x. That's a -12x. and negative 3 and negative 8, and that's negative 11. So this winds up being your derivative for that product. Now, one of the things that shows up with the product rule is, can you recognize the notation and apply it when you have a numerical product rule? So taking a look at this again, if the function h of x is a product of f and g, find h prime of 2 given the following. So here's what we have here. Now, we know by the product rule right here, first times derivative of the second plus second times derivative of the first, that if we write it out with a 2 in place of this, all we have to do is follow what was given. So it's first, which is f of 2, times the derivative of the second, g prime of 2, plus the second, g of 2, times f prime of 2. And now all we have to do is plug in what we know here. F of 2, that's equal to negative 2, times g prime of 2, that's negative 5, and then g of 2, which is 4, times f prime of 2, which is 3. So this is going to give us a 10 plus 12, and we have a numerical derivative here of 22. So that's just recognizing the notation and being able to apply it with what was given here. So that's the product rule. So let me scroll over now, and we'll do some quotient rule examples. So as you can see here, I've got the quotient rule here. Two things divided. It's the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over bottom squared. So if I'm trying to find the derivative here, it starts in the bottom. So bottom 2x minus 3 times the derivative of the top, which is 1, minus the top, x plus 5, times the derivative of the bottom, 2, all over 2x minus 3 squared. Now, you don't have to oversimplify this. I'm just going to combine some like terms on the top. I know I'm going to have 2x minus 3 minus 2x minus 10. So don't forget that negative in distributing the 2 there. And so I know the x's are actually going to cancel out here. I'm going to wind up with a negative 13 all over 2x minus 3 quantity squared. That's going to be my final derivative there using the quotient rule. Try one more over here. And the derivative again here, we're going to start at the bottom. 4x squared plus x times the derivative of the top, 2, minus the top, 2x, derivative of the bottom, which is going to be an 8x plus 1, all over the bottom squared, 4x squared plus x quantity squared. And again, on the top here, we're going to wind up, when we distribute the 2, 8x squared plus 2x minus 16x squared minus 2x. So combining some like terms, we're going to have a negative 8x squared. 2x is canceled. That's not going to happen every time. That actually happened in the other one. Just a coincidence. So negative 8x squared on the top, all over 4x squared plus x quantity squared. And there's our derivative for that quotient rule. So just like we did with the product rule, let's finish this one off with being able to do a numerical derivative here with the quotient rule. So again, we got h of x is now f of x divided by g of x, then find h prime of 5. So we're just plugging 5s in right here. So it's the bottom g of 5 times the derivative of the top, so f prime of 5, minus the top, f of 5, derivative of the bottom, g prime of 5, all over g of 5 squared. Alright, let's fill in g of 5. What was that given? That's negative 1 times f prime of 5, negative 2, minus f of 5, that's 5, times g prime of 5, and that's 4. So this is going to be a 2 minus a 20 all over g of 5 squared. So that's 1. So 2 minus 20, that's negative 18 over 1, which is negative 18. So there's our numerical derivative using the notation for the quotient rule. So hopefully with those quick examples, that kind of clears things up for you on finding some basic derivatives with polynomials and with the product and the quotient rule.